Today's lesson is on growth and decay. We actually have 3 different growth and decay models that we're going to look at. The first one is simple growth and decay. This is a linear model, and this equation looks like A equals P times 1 plus R times T, and we're going to define all of the parts. So this is very straightforward. A is the final amount, or what you're looking for. Now sometimes in a word problem it's going to give you that amount and have you work backwards, but that's the final or the total. Then P is your initial amount. In some of our formulas it's P of O, P of 0, it's that initial amount. Then R is your rate of increase or decrease. We have to be sure that we are converting our decimal or percent to decimal before we put it in this formula. And then T is the number of time periods. How many times, usually years, because we're usually looking at interest, so how many years you are collecting interest or how many years you're paying interest. All right, now notice that this is going to be a linear model. We do not have any exponents in this model, so it is linear. That means our graph is going to look like a straight line. Our second model is compound growth or decay. Now, just like simple, this can grow or decrease. This one is going to be an exponential model. Okay, we usually will see this used in finances, but it can also be used with radioactivity. It can be used with population, but usually finances, radioactivity, those are what you will see problems using it for. That didn't sound very good at all, did it? My English is terrible. All right, so this function is going to look like P of T equals P of O times 1 plus R. This is looking real familiar so far, isn't it? But here is where we're going to change it from simple interest. We're dividing by N and then raising it to N times T. So this first part looks very much like simple interest, but then the second half is where it diverts and becomes exponential. So let's see what all of these things stand for. So P of T is the final amount, just like A was in the simple interest formula. P of 0 is the initial amount, our y-intercept, just like P was in the simple interest formula, and it has been in all of our other formulas. It's our y-intercept. R, again, is the rate of increase or decrease. We have to convert it from the percent to the decimal before we put it into the formula. Now here's where this one changes. N is the number of times compounded yearly, or compounded in a year. Now, what this is going to look like in a problem is, what this is going to look like in a problem is words like quarterly, that means every 3 months. It may look like annually, that means once a year. It may be daily. Let's see, monthly. So quarterly, there are 4 quarters in a year. Annually, that's 1 time a year. Daily, there's 365 days in a year. Monthly, there are 12 months in a year. These are the numbers you would put in if you were compounding, if your problem had these words after compound. Okay? And then T, again, is the number of time periods that your money usually is being put in that situation. So if you are compounding quarterly for 3 years, the N is going to become 4 because that's your quarter, how many times during 1 year it's being calculated. This N becomes 4, but since it's going to be in the account for 3 years, the t becomes 3. Okay? So it's total number of years. This becomes total number of years that you are in that situation. The n is the times compounded, which are these words down here. Okay? Okay, our third model is continuous growth or decay. Now again, this is an exponential model. We are going to use this one for population. So anytime you see a population problem in our class, you're going to use the continuous growth model. Now this function looks like P of t equals P of O times E raised to the RT. Now, a couple of things I need you to notice. This O is subscript, okay? P of O, if you look down here, just like before, P of O is our initial amount. It's our y-intercept, okay? The E is new. E, it's a number just like pi. All right, it has an actual value. It is always the same value. It's approximately 2.71828, but just like with pi, if we use 3.14 for pi, it changes the actual value. So on your calculator, there isn't a place that we can bring up E, and I'll show you that in class. So this is our base. Okay, E is going to be the base of our continuous growth and decay. So that is something to remember here. Continuous growth and decay is base E. Okay, and then R is exact same thing. R and T are the same thing they were before, but notice this is, both of these are in an exponent. Okay, so it looks like a big old mess going on, but really we have got our initial value times E raised to R times T. Okay. All right, so P of T is still the final amount like it has been in the other two. R is still the rate or rate of increase or decrease, and we are going to convert those percents to decimals, and T is the number of time periods, usually in years. So I need you to look over these equations, make sure you know what all of these mean for all three of them, and we will practice them in class. And that's it.